Thank you for joining us today. You're looking at Enercon's virtual PAC Expo booth here in Menomonee Falls, Wisconsin. I'm Jessica Tellner. I'm one of our sales managers, and we have with us here Jeff LaGrange, our product manager.
Hi, everybody.
Today, we're going to go through how you can achieve a perfect seal by setting an operating window. Jeff, what's an operating window?
Well, an operating window is generally, it represents the range of power levels that you can use to achieve that perfect seal. You control all the system variables and then run containers through at different output levels. If you've got too little power, you're going to get a weak seal or no seal. If you've got too much power, you're going to overheat. What we're looking for is that right amount of power that you can use to get that perfect seal. It's kind of like Goldilocks and her porridge. It's just right.
Now let's take a look at a short video that Jeff pre-recorded that covers best practices for sealer setup.
Before we start setting up any windows, we have to make sure that the sealer is set up properly. Here you see some views. You have to make sure that the bottle is going down the center of the coil. There are center line stickers on all of our coils. You use guide rails on your conveyor typically to make sure that happens. You also have to set the air gap and make sure that it's even. So your coil must be parallel to your conveyor. Well, how do you set that up? Well, Enercon will provide you with a gap gauge with every order. Depending on the type of coil you're using, you can either put the gap gauge under your bottle and then lower the coil down to the top of the bottle, or you can put the gap gauge on top of your bottle and lower the coil down to the gap gauge. That will give you your optimal 1/8" air gap.
And Jeff, once the sealer is positioned properly, what's the next step in creating an operating window?
Well, you've got to get some containers. The best practice is to use the containers that you're going to actually be sealing and make sure that the product is in them, because the temperature is going to have an effect on the seal. You should also make sure that you're sealing products that have been capped with your capper, not by hand. You don't want to be capping by hand if you're going to be using the capper. You want to run at production line speed. Once you've done all that, the only thing left is the output power of the sealer.
That makes a lot of sense, Jeff. So let's take a look at a short video that covers the process of setting up an operating window and finding that Goldilocks setting.
So let's talk about how we do that. We're going to pick a power level, in this case, 40%. We're going to run at our production line speed. We're going to run one bottle and check it. In this example, at 40%, we get no seal. So we increase by 5%, go to 45%, we still get no seal. So we increase by 5% again, and now we're starting to get a partial seal at 50%. So we're almost there, we've got a partial seal. We increase by 1%, 51, we're still not quite there, so we increase a little bit, 1%, 1%. Eventually, in this example, when we get to 58%, we decide there, that is a good seal. So we can mark that as our minimum, and now we're going to move on to the maximum. So we start at 58%, we're getting a good seal, we increase by 5%. We're still getting a good seal, we increase by 5% again. Oh, now we're starting to see some overheating. Maybe the cap is starting to smell like it's burnt or something like that. So we dial it down by 1% at a time. 68 down to 67. Oh, still burning. Eventually we get down to 65%. We say, okay, that's still a good seal. It's not burning. This is our maximum. So now we've established that the minimum is 58%. Maximum is 65%. So that is our window. So in this graphic, you can see 58, 65. If we wanted to go in the middle here somewhere, we would be about 61, 62%. Give us a little bit of cushion as our variables inevitably change, and we would still stay within our good seal window.
So Jeff, should a packager do this for every application that they seal?
Basically, yes. And it's important to document all of these settings, because later down the road, if you get results that you weren't expecting, you can go back and look at, what your sealer power level was, what your conveyor speed was, and what your sealer alignment was.
Do you have any other tips for troubleshooting induction sealing, Jeff?
I've got lots of them. But generally, the seals themselves will tell you generally tell you what's going on. You can look at them and they'll tell you what's happening.
Let's take a look at a short video now of an overview of what to look for if you're not getting good seals.
First option, if you're not getting good seals, that you're getting no seal at all, which obviously means the liner is not sticking to the bottle at all. There's a couple basic things that you need to cover. Did you remember to turn the sealer on, and is there a liner in the cap? Those are pretty simple. Beyond that, there's things that we can look at that can cause a lack of seal. And there's a question you should ask. If you were sealing this application properly before and now you're not, what has happened? What has changed? Perhaps the torque coming out of your capper is no longer sufficient to get a good seal. Maybe your operator has changed the line speed, or the line speed changes by itself sometimes. Or maybe the operator has changed some of the settings on the sealer. Maybe the power level, maybe the air gap has changed. Also, something else you need to consider, if you've got the wrong kind of a liner for this bottle, it's just not going to stick. If you've got a polyethylene liner and a polypropylene bottle, they just aren't going to stick very well together. And you also have to consider that maybe your purchasing department decided that they could save a half a cent a liner if they changed to this other one, and now suddenly it doesn't work anymore. So those are some things to look for if you're getting no seal.
So it looks like the lack of cap application torque can be a big problem, even if you have the rest of the system set up properly.
Yes, that's basically the #1 cause of leakers, just inadequate or insufficient or inconsistent torque.
I believe our next video shows how lack of torque can be a cause of a partial or inconsistent seal.
What if you're getting a partial seal? You know, in this example, it's sticking on one side but not on the other. What could be going on there? Well, one thing, probably the first thing to look for is your application torque. If that liner is not in intimate contact with the land area, you can heat it up all you want and it's still not going to stick very well. Also, you need to consider there is a balance between the output power and the line speed. And if you mess up that balance, things aren't going to seal very well. So if your line speed's too high or the output is too low, you're going to get a partial seal. Or maybe the caps are not going under the center line of the coil. If they are offset to one side or the other, you can get this uneven heating that we see here. We talked earlier about the leveling the coil with the conveyor. Not necessarily level with the floor, but it's got to be parallel to the conveyor. These are some things to look for if you're getting a partial seal. There's also a possibility you've got some problems with your materials. If your bottle has a sag or a saddle in the land area, you can torque it down all you want. You're not going to get good contact, and therefore you won't get a good seal. We talked a little bit about the liner compatibility. Or what if the cap, as you screw it all the way down, it bottoms out on the shoulder before it is bottoming out on the land area like it's supposed to. So you've got an interference problem there. You're going to get a weak seal or no seal in that situation.
So we've looked at no seal and partial seal troubleshooting. Is there anything else that we should go through?
Yes, we've got one more scenario really. Many packaging operators feel that if some power is good, more must be better. That simply isn't the case.
So you're saying if you don't establish the top of your operating window, you can run into problems?
That's right. You can see foil wrinkling. You can damage the underside of the liner. Scorched pulpboard can happen, and sometimes it just stinks. And nobody wants that in their package.
Thanks, Jeff. So we have one more video for you that's going to go into what can happen with overheating.
Lastly, we've got an overheated seal. This image is pretty extreme, but it kind of shows what we're looking for. So if you're overheating the liner, you'll sometimes see some wrinkling in the liner. You will almost definitely be able to smell that the liner is overheating. In this picture, I'm sure this cap smelled terrible. You'll get a little bit of pulpboard discoloration again, this picture is pretty extreme, but you should not see any browning around the outside of the pulp board if you've got a two-piece liner. If you've got a one-piece liner, maybe it's got a foam backing, you should not see that foam melting away from the edge of the liner. Now, the reason for an overheated seal is pretty simple. You've either got the power set too high or the line speed is too low for the power you're using. Again, I'm talking about the balance between line speed and power. So you've got to find that balance, and to do that, you really need to go back and find your sealing window for this application.
So thank you again for joining us. Just to recap, a few of the things we went through today to help you find and achieve your perfect seal. Make sure your cap torque is proper. Make sure your sealer is set up properly. Anything else you want to add, Jeff?
That pretty much covers it. Make sure you've got good products going into it. So if you've got an unknown liner and it's not acting right, there's a good chance it's a problem with the liner. Something has changed.